Okay, class, today we're going to go over section 4.3, the multiplication rule and the conditional probability. So this is in your workbooks on page 110. All right, so we started with lots of vocabulary. First of all, independent events. So two events, A and B, are independent events if the fact that A occur does not affect the probability of B occurring. Okay, I'm also going to add to that definition one event is a factor that makes it no more likely or no less likely for the second event to occur. So here are examples of independent events. So rolling a die and getting a 6, and then rolling a second die and then getting a 3. Okay, I'm going to draw a picture for that here. Okay, so again, these are independent. So this would be considered event A. Rolling a die and getting a 6 does not affect the probability of B occurring. This is event B. Rolling a die and rolling a 3. Okay, another example. Drawing a card from a deck and getting a queen, replacing it, and then drawing a second card and getting a queen. Okay, so I happen to have a deck of cards here. There's 52 cards in a deck of cards. So they say you draw a card and you get a queen. Okay, and they didn't restrict it, like they didn't say what suit it comes from. So we have a suit, we have 4 suits, right? Queens, diamonds, these little flowery things are the clubs, and then the spades. But they didn't restrict us. They just said drawing a card and you're going to get some kind of a queen. But then you put the card back into the deck of cards, right? You put the card back into the deck of cards, and then you draw the second card, and then you get happen to get a queen again. Okay, so because you replace the card, that's what makes these events independent. Okay, so I'll draw a little card here with a Q for queen and a heart, and I'm going to call that event A. And then you replace the card, get another card, and they're saying you get a queen, and I'll just suppose it was the diamonds. Okay, and that would be event B. But because you replace the card, this is important, these are considered independent events. So it says to find the probability of two independent events that occur in sequence, you must find the probability of each event occurring separately, and then you multiply the answers. And they call this multiplication rule number 1. When two events are independent, the probability of both occurring is probability of A and B, which is probability of A times probability of B. So they have some examples here. Let's say you're tossing a coin. A coin is flipped. So I happen to have a coin here. And they're saying that it's flipped and then a die is rolled. Find the probability of getting a head on the coin, and then you're rolling a 4 on the dies. So when we set up probabilities, we put a capital P for probability, and then we put a little bit of description. So we want a head on the coin, and we want a 4 on the die. And remember how they treat the idea of success. The idea is you're getting ahead, so that would be considered success over your outcomes. Okay, so for us, success is getting that head over the outcomes, which is a head or a tail. Okay, so this would be probability would be 1 over 2. 1 representing the head, and then 2 outcomes. When you roll a coin, you can get a head or a tail. So that would be the first probability. Second probability, and so I can actually do this. Let me see. Let me go back. Let me do this. So let me do probability of head. Oh no, yeah, probability of the head times probability of the 4 on the die. Okay, so the probability of head is the 1/2. Whereas the probability on the die, you want to get a 4. And then your choices on the bottom is you could get either a die that has a 1 on it, or a die that has a 2 on it, or a die that has a 3 on it. And then there is the option of the 4, which is what we wanted. There's also the option of the 5. And then there's the option of the 6. Okay, so that's a total of 6. 1, 2, 3, 4, 5, 6. 6. So that's your denominator. And in the numerator, you just have 1. There's only 1 4 that can pop up. Okay. So you have 1/2 times 1/6. And remember to multiply fractions, multiply fractions straight across. So 1 times 1 is 1. 2 times 6 is 12. And that happens to be lowest terms. You cannot reduce that anymore. Okay. Okay. And then I'm gonna read this comment that I believe I got this from your ebook. I believe I got this from your ebook. So it says that when a small sample space is selected from a large population and the subjects are not replaced, the possibility of the event occurring changes slightly, such that for the most part it's considered to remain the same. So each of those randomly selected is treated as an independent event. Okay, and their probabilities can be multiplied. Okay, so I believe I got that from the ebook, so that's kind of summarizing, right, this idea here. Okay, now another example of multiplication rule number 1 that you see in your textbooks is something like this. So a Harris poll found that 46% of Americans say they suffer great stress at least once a week. So I'm actually going to let S denote Americans who suffer great stress at least once a week. Okay. If 3 people are selected at random, find the probability that all 3 will say that they suffer great stress at least once a week. Okay, so I'm going to put a probability, but since I've already said S are representing the Americans who suffer great stress, and since we're selecting 3, we're selecting at random 3 people, I'm going to use subscripts S sub 1 and S sub 2 and S sub 3. And that's because that's related. I'm trying to apply the definition. See this here? I'm doing this part. And then now I'm going to do this part here. So I have 3 subscripts. 1, 2, 3. I have 3 subscripts because 3 people were selected. And of course, that's important, right? Randomly is super important. Randomly selected. And then for this part of the vocabulary right here, this part, so I have probability of S sub 1 times probability of S sub 2 and times probability of S sub 3. Okay. Now here on the probabilities, these probabilities happen to be the 46%. The 46% is our probabilities here. So whereas in this problem, you had for the head 1/2 times the die 1/6. Okay, here your probability is this 46% times 46% times 46%. Okay, so if you want to use exponents, you may. 46% raised to the 3rd power, 1, 2, 3. And when you work with percents, you oftentimes you have to change the percent to decimal. So you're gonna have to move it left twice. So this actually becomes 0.46 raised to the 3rd power. And then you have this key on your calculator, the caret key. You want to use that key. So you type in your base, then you hit this key, and then you type in your exponent, and then you hit enter. So your base is 0.46, and then you're going to raise it to the 3rd power. And then that gives you this value here. And then what I'll do is I'll change this is a decimal. I'll change it to a percent because oftentimes, you know how it started off as a percent, 46%. So oftentimes your Connect Math will probably want you also then to put it as a percent because it started off as a percentage. So if I do that, I can do here times 100%. So times 100 equals, and now it's about 9.7336%. And then they'll either ask you to round to the nearest whole, because this was the whole percent, or they'll say round to nearest tenths. So if I round this to nearest tenths, then this 7 is in the tenths place. And when I look at the number to the right, is the number to the right 5 or more? No, that's a 3. So it's about 9.7%. But if they ask you to round to the nearest whole number, the nearest percentage, then you would highlight the 9 and you look at the number to the right. Is that 5 or more? Yes, it is. So then it would, and then you would add 1 to the 9. That'd be 10%. Okay, so it just depends on the percentage that they want. Okay. Okay, now there is another problem like that in the workbook at the bottom. If you look at the bottom of page 111, the next page, they do have another example at the bottom that has to do with what we just did, this multiplication rule number 1. And remember that said, that property said probability of A and B is equal to probability of A times probability of B. And remember, these are considered independent events. And I'm actually going to change this because otherwise it's too similar to the first problem that we did. Or it was too similar to the one we just did about the stress here, because they also selected 3 people. So I'm going to just change this so it's not so similar, and I'm going to change it to 2. So let's say the Gallup poll reported that 56% of Americans want to lose weight. And if 2 people are selected at random, find the probability that they all want to lose weight. Okay. So here I'm gonna let W denote Americans who want to lose weight. And since we're only selecting, I changed it to two people. I'm going to have probability of W1 and W sub 2 is equal to probability of W1 times probability of W sub 2. And the percentage that we have is what was it? 56%. So this is 56% to the second power. Okay. Because you have two of them. And this is equal to 0.56 to the second power, because you have to change this percentage into a decimal. And then when you use your calculator on that, 0.56, and then you raise it right here, the hat key, to the second power is equal to this. This is your decimal. And then if I multiply this down here by 100% times 100%, that gives me about 31.36%. And if they ask me to round to the nearest tenths or percent, this is the tenths place. So they look at the number to the right. Is this 5 or more? Yes, it is. It's a 6, so add 1. So you have about 31.4%. Okay. So that uses the multiplication rule. That's considered, these are considered independent. Okay. Now at the top of the page, they have some definitions for dependent events. So at the top, they say that when the outcome or occurrence of the first event, when it affects the outcome or the occurrence of the second event in such a way that the probability is changed, the events are said to be dependent events. Okay. And so let me just see if I had a, did I have a supplement? Let me just double check. Did I have a supplemental definition to add? Like I added a supplemental definition on the first one. But no, I guess not. No, just double checking. Okay. All right, just double checking that. All right, there's okay, double checking. I thought I had an extra, but okay, but not. Okay, so then, here's some examples of the dependent events. So drawing a card from a deck, and then you're not replacing it. Okay, so you draw a card from a deck. Let me just shuffle these a little bit. So I'm drawing a card from a deck, like this one, 8. But then I'm not going to put it back in the stack. I'm going to just keep it separate. And then I'm going to draw a second card. Okay. Oh, Joker. Okay. So then these events are considered, this would be something to be considered dependent, because first, when you have this first card, you have 52 cards in the deck. That's your denominator. But then you don't put it back in the stack, and now you choose another card, and you don't have 52 cards in the deck anymore. Now when you get ready to choose a second card, you don't have 52 cards in the deck. You've got one less. You have 51 cards, and then you're choosing your joker. So is what I drew. And so these events are considered dependent. Okay. So um, by you not putting the card back, that does affect the outcome of the second choice. Okay, because this is no longer a possibility because you didn't put it back in the stack. Then they say having high grades in college or in high school, right? Having high grades and then getting a scholarship. Yeah, so having high grades, good grades, um, and then getting a scholarship. Yeah, so the first event, which is getting good grades in school, does affect the outcome or the occurrence of the second event. Yeah, because if you have bad grades, then you're likely to be chosen, right? It's very competitive for a scholarship. So you want to have good grades because they want to provide monies to people who are going to finish, right? Study and finish the course and pass their course, right? They're going to support them in school because they complete their work. Okay. Parking in a no parking zone, and then getting a parking ticket. Okay. So right. So if you park in a zone, they ask you not to park there. They're probably going to have policemen patrolling the area and things like that, checking for that. Yeah, so you're likely to get a parking ticket. They don't want people parking there for some reason, so you're gonna have to double check that, and it's possible you could get a ticket because they told you not to park there. So these first events make it more likely, okay, to affect. They do affect the second event, okay. And then they say here, determine whether these events are independent or dependent. And so they have here drawing a card from a deck and then not replacing it, and then drawing a second card. Okay, so that we saw right over here. That looks like this one, drawing a card from a deck, not replacing it, and then drawing a second card. Yeah, so that we saw over here. And they said that was an example of a dependent events. Okay. So let me see. So I did write some comments at the top. Let me see. I did write some things at the top here. I'll add them in. So for the first one, I put here that I have this circled, and I say that not replacing the card causes the probabilities for drawing the second card to be changed. Yeah, and I can make this, I guess, singular instead of probabilities, probability. And then for the second one, having high grades and getting a scholarship. So I put your ability to receive the scholarship is dependent on your high grades. So I have here that the high grades makes it more likely. Makes it more likely. And then parking in a no parking zone is a factor making getting a parking ticket more likely to occur. Okay. Okay, let's see. Let's look at the next page. Okay, this is called multiplication rule number 2. When two events are dependent, the probability of both occurring is probability of A and B is equal to probability of A times probability of B, given that event A has already occurred. So there is a, you can see that there is a bar here, a line here means such, this bar means, you know, such that, right? We know that it's such that. Um, and actually, okay, it does mean such that in set notation, but actually for probability, we're going to treat that as actually the word given that. So this part is um, read probability of B given that event A has already occurred. Okay, so I also have a note that says at the top that when the occurrence of the first event changes the probability of the occurrence of the second event, then the two events are dependent. Okay, so these next two problems, they are examples of the multiplication rule, but they were their computations are kind of already somewhat figured. Um, so these would be a little bit easier than the next set, the next page that we're going to do. And then, but the next page of what we're going to do is more like what you're going to see on your homework. So I'll go ahead and do these problems here, but your homework on the multiplication rule, concerning the multiplication rule, will be more like the problems that we'll see on the next page. Okay, so this is just like a rough sketch of the idea, just to get your feet wet. Okay, so it says that overqualified workers. In a recent survey, 33% of the respondents said that they feel that they are overqualified. And they use O for that, for their present job. And then among this group of this group, of that group within the 33%, then 24% of that group, 24, said that they were looking for a new job. Okay, and they call that J. If a person is selected at random, find the probability that the person feels that he or she is overqualified and is also happens to be looking for a new job. Okay, so we would start with probability. I'm going to put here overqualified and looking for a new job. Okay, so I get that from here, right? So this is going to be probability of O and J. Okay, so we have probability of O, which was the 33% times, and then the probability of O has already occurred, right? So so this is now probability of the second event, J, given that the first event has already occurred. So then of the 33%, then they surveyed that group, and then they found out that 24% that said they were looking for a new job. So these have already been figured for you in that sense, and so all that's left to do is multiply. And so 33% is 0.33 as a decimal. 24% is 0.24 as a decimal. So you just move your decimal. Two places to the left. And then on your calculator, when you multiply, so move your decimal two places to the left. And then when you multiply on your calculator, 0.33 times 0.24 is this. And then if they want a percentage, because these are in percentages, then we would do the times 100%. Okay. No, I'll just leave it. I'll just leave it like that. I won't round it. Sometimes I round to tenths, or sometimes you want to make it to the nearest whole percent. 8 would be the nearest whole percent. I'll just leave it like this for now. And this one says that homeowners and automobile insurance. So Worldwide Insurance Company found that 53% of the residents of the city had homeowners insurance with the company. And then among that group, within that group, 53%, then turns out that then 27% also had automobile insurance with the company. If a resident is selected at random, find the probability that the resident had both homeowners and automobile insurance with Worldwide Insurance Company. So I'm going to use their letters, probability of H and A. So I'm using, here's your H and here's your A. There's homeowners insurance, automobile insurance. So this is probability of H. And that was the first percentage, that was the 53%, times probability of the second event, which is the A, given that the first one had already occurred, so which was the H, and that gave us the 27%. Okay, and I'm going to change these to decimals. I'm going to move my decimal two places left. So you you barely see it. Well, the decimal is hidden in the back, right? Then you move it 2 places over to the left. You get that. And then if I multiply that, 0.53 times 0.27, 0.1431. And then if I multiply that times a percentage, 14.31%. And again, if I leave that alone, that's the nearest hundreds. If I leave that to nearest hundreds and I don't round it, if I wanted to nearest whole percent, that would just be 14%. Okay, now we're gonna continue with the multiplication rule, but these are more like the problems that you're gonna see on your homework. And the idea here will be that um, because these events are dependent, that when you set up your fractions and you multiply your fractions, when you set up your fractions, you're going to want to be subtracting. Sometimes you just subtract from your numerator, and sometimes you subtract also, from your denominator. Um, and sometimes in some problems, you're just subtracting from your denominators. Your denominators are changing. It just depends on your situation. And so we'll show you some of both types. But for the most part, you are going to be setting up fractions and multiplying straight across. You just want to make sure you set up your fractions correctly. Okay. So I'm going to put the rule at the top. That would be multiplication rule number 2, and letting you know that these are dependent events. And the keyword, one of the keywords is not replace. That's helpful if you're working with cards, right? It's helpful, not replay, but that's a keyword. And then the formula is probability of A and B is equal to probability of A times probability of B, given that the A has already occurred. And that's why you have to do your subtractions. So here's our first example, part A. 3 cards are drawn from an ordinary deck. So there's 52 cards in an ordinary deck, and they're not being replaced. So that's important. And that's how you know you're going to have to use multiplication rule number 2 as opposed to multiplication rule number 1. Um, and in multiplication rule number 1, there were no subtractions going on. They were pretty much just multiply straight across, right, for the most part. But you're going to see here that you'll have to do some subtractions for multiplication rule number 2, because things are not being replaced, not being put back. So your 3 cards are drawn from an ordinary deck and not replaced. Find the probability of these events, that getting 3 jacks. Probability of getting 3 jacks. And so I'm going to say, go ahead and let J denote choosing a jack card. Okay. So when I'm going to use this definitions, I have probability of J1 and J2 and J3. So remember, I'm going to use your teacher's using 3 subscripts, 1, 2, 3. Why? And that was because um, 3 cards are drawn. Okay. And then this is equal to probability of J sub 1. And then if you look at your jacks, um, how many jacks do we have, right? So in a deck of cards, you have 4 jacks. Okay. And that's why you need that sheet, that you need to print that sheet if you haven't done so already. In your module 7, you do need to print this sheet here, because this will also show you your jacks right here. See, jack of hearts, jack of diamonds, jack of spades, and the jack of clubs. Okay, so you do have 4 cards to choose from. Okay, so so that's why your numerator is going to be 4, because you have the jack that's a heart, and the jack that's a diamond, and the jack that's a spade, and you have the jack that's a club, and then there's 52 cards in the deck of cards. Okay, but then it says you draw a card and you draw the jack, but then you're not putting it back in the stack. You're separating it. Now you have these cards. So now you want to have the second choice, probability of picking the second one. But given that this first event has already occurred, which is over here, which is, you got a jack already, so you put it over here. So now um let's suppose that you drew this one. Let's say I have this circled. Okay, let's suppose that we drew that one, and you're not replacing it. So then now what's left? So now what's left is the jack that's a heart, and the jack that's a diamond, and the jack that's a club. So you have 4, take away 1. Here's where your subtractions come in, and then 52 take away 1. So that gives you 4 over 52 times 3, because 4 take away 1 is 3, 52 take away 1 is 51. So now you have 4 over 52 times 3 over 51. So see, this has decreased some subtraction, and this has decreased. Okay, so you don't have 52 cards now, you have 51, because remember they said this one wasn't being replaced, and now you have, these 3 jacks that could possibly be picked that are in here. I mean, you're interested in the jack, and so you got 3 that could possibly be picked. But then let's say you pick this jack of hearts. Let's say you pick that one, and so let's say when you did your second drawing, you picked the jack of hearts. That was out of the picture. Okay, but you got now another probability. You got a third card to draw. So now you have times probability of the third card, but given that the previous has occurred, and the previous is this, it's J sub 2 given J sub 1 has already occurred. Okay, so then this is 4 minus 2, and this is 52 minus 2. Okay, And so and so now you're left with two jacks, and one of these can be picked. So let's just pretend you got the diamond. So here you're down to the jack that's a diamond and the jack that's a club. And let's say the diamond is pulled out. And 4 minus 2 is 2. So you have 2 to choose from. And let's just say that the diamond got pulled out. So it's 2 to choose from. And then 52 minus 2 is 50. Yeah. And then there's not a need. I know you have one more jack lurking around, but there's no need to worry about pulling it out because they only said that you were going to pull out 3. They didn't say you're going to pull out 4 cards. They only said you're going to pull out 3. So that so never you mind about that extra jack that's lurking around. And so now you're going to multiply across, straight across. That's how you multiply fractions. So you have 4 times 3 times 2, which is 24. Then you have 52 times 51 times 50. And that's a big number. It looks like 132,600. And you know that can be reduced because even numbers in a 0, a 2, a 4, a 6, and an 8. So you see this is in a 4 and a 0. So you know even numbers are reduced by 2. You know you're safe by reducing by 2, and this is a big number. You might just have to reduce by 2 several times. But also your calculator might be able to handle that by using the math frac button. Um, and so first, though, you have to change it to a decimal to use the math frac button. So and sometimes you want to write your answers up as a decimal anyway. So this is 24 divided by 132,600. Ooh, and look how small that is. That's a very small number. See that e to the negative 4? That's actually times 10 to the negative 4th power. That's actually what that is. That's times 10 to negative 4. This is a very small number. This is a very small number, 10 to negative 4, because it's negative. This is this small number because it's a negative 4. If it had been a positive 4, I would have considered that big. But because it's a negative 4, this small number makes the 1.809 dot 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 makes this number small too. That's the effect. That's the effect that it has on it. So to make that number small, you move your decimal left 4 times. But this one actually counts as one of the moves. 1, 2, 3, 4. So I'll be formal here. So I really need 3 zeros, and then there's that 1 that counts as a move. And then you don't forget about these. You need all those digits there too. And see this is very small, and usually we round to the thousands place usually, unless like if I round this in your thousands, then is this number 5 or more? No. Then that would be 0.000, and they don't want you to record in statistics to record a 0 unless it's truly 0. So for that reason, instead of rounding to the nearest thousands, they would have you round to nearest 10,000s. So you have tens, hundreds, thousands, 10,000s. And then look at the number to the right. Is that 5 or more? Yep, it's an 8. So you have 0.0002. Okay. And now let's go back to the fraction. Let's, because we were talking about reducing that. So now that I have this decimal, you would, to make into a fraction, if the calculator's tolerance is high enough and it can do that, you would press the math button. And then you have this one frac button, and then you hit enter. And then you go ahead and hit enter again. So I'm going to hit enter again. See how it reduced it? 1/5,525. So I got reduced. Okay. Sometimes the calculator can't reduce it. Like it's supposed to be reducible, but the tolerance isn't there. And sometimes you have to reduce it on your own by hand. And that would be like if you know your divisibility rules and you recognize, hey, they're both even numbers, so they should be able to be reduced by any 2. Sometimes you have to do it on your own by hand. So we'll do some by hand that you have to reduce. We'll do some in this section. Okay, so that was part A. Now for part B and for part C and for part D, I think I sent you on an email about printing some extra PDFs in your module 7 concerning test 2 for both the 4.2 and the 4.3 section. So if you printed that, one of those 3 pages had part B, C, and D. And if you didn't print them, then you can just follow along and then just definitely get some clean paper out. And so let me get mine out. Yeah, so here's part B. So you see it says getting an ace, a king, and a queen in that order. See? And then C, getting a club, a spade, and a heart in that order. See? And then getting 3 clubs. See that? So yeah, so I just set those up there. Okay. All right, so let's see. All right, now what I'm going to do is so for the practice the idea would be you would denote a letter. You would denote a letter to represent what you're choosing, and then you would follow through with the vocabulary. So in your multiplication rule number 2. So I'll go and do that one more time for the top one, but then the second and third, because we keep choosing 3 on all these cards, all these probabilities, we're choosing 3. So really it's very similar because we're choosing 3, but the idea would be like, let's say, let X denote, and what we're doing here is we're choosing an ace, a king, and a queen. Okay. So you remember when we did this previous problem, I let J denote choosing a jack card because we were trying to get 3 jack cards. So I let J denote getting a jack card. So here we want to get an ace, a king, and a queen card. Okay. And I can't even say face card because face card doesn't include the ace. Face card is just jack, queen, and king. So I can't even summarize it and say a face card. The ace is not a face card. So I have to say ace, king, and queen. So we're going to let X denote that. And then we would say, let me take this off here. Let me put this over here. And then I would have probability of X sub 1 and X sub 2 and X sub 3. And again, I'm using 3 subscripts because we're um, we're choosing 3 cards. And of course, this is random, right? Random choosing. And then you have probability of X sub 1. So for that first probability, you're choosing only an ace. Ace only. Okay, well let's see what our options are for the ace card. If you look at your cards on the ace, you have 4 to choose from. There's the heart, the diamond, the spade, and the club. So I'm going to write those down. Okay, but that means you've got 4. So here your numerator is going to be 4 to choose from. Any of these can go, any of these 4. So you got 4 to choose from. And then your denominators, there's 52 because there's 52 cards and a deck of cards. Okay, then you have times probability that you're going to choose X sub 2, given that you already chose X sub 1. So remember what happens. Remember they said that you're not replacing it. So let's say if I find my ace cards, let me find an ace card. Here are my ace cards. Let's say I pick out the ace of hearts. Let's say that one got chosen. And then you're not going to replace it. You're not going to put it back in the stash. You're going to keep it separate, away from that, right? So now when you choose your second card, you're going to choose your second card, and your second chart has to be a king. So a king only. So you have the king of hearts, the king of diamonds, the king of spades, and the king of clubs. So you got 4 cards to choose from. So again, it's times 4 because you have 4 cards to choose from. Any of those can work. But then the denominator, remember, because you took this card out, you don't have 52 cards in the deck anymore because you took that card out and you didn't replace it. Now you have 52 minus 1. So now you have 4 over 52 times, again, 4 over 51. So this is a problem where your denominator is changing. You're subtracting the card out. Denominator is being decreased, but the numerator's not because of what you're choosing. Here you want to choose an ace. There's 4 to choose from. Here you want to choose a king. And let's say that on the king, let me look for a king. Okay, here's a king. This is the king of spades. So let's say that it was the king of spades that got chosen out randomly. And then you're not going to replace it. So you're also going to put it over here in the stash and you're not going to replace it. So, and so now you've got a third card to choose. When you choose your third card, now your denominator is 52 minus 2 because you've got these that you're not replacing. And then when you choose your third card, this is times probability of x sub 3, given that the previous event has occurred. And so you record your previous event, and that would be that this x sub 2 given that x sub 1 occurred. That was the previous event. And when you're choosing the third card, they said it has to be a queen. So when you look at your queens, heart, diamond, spade, club. So again, you have four to choose from, four queens to choose from, okay? So now you have 4 over, and 52 take away 2 is now 50 cards to look at, to choose from. Okay. And you're going to choose one out of that, okay? Okay, and then but then you can stop there, because you don't need any more fractions because you already chose 3. They're choosing 3 cards. So then you just multiply straight across 4 times 4 times 4, which is 64. 52 times 51 times 50. Wow, it's a big number. 132,600. Okay. And then I'm going to make that into a decimal. 64 divided by 132,600. So you see, it's not surprising that the denominator is this. We saw that denominator on the first part because the denominators were 52 times 51 times 50. But this is also a very small number. See that? Times 10 to the 4th, negative 4th. We have 1, 2, 3, 4. Okay, so you need 3 zeros, and then this 4 counts as a move. You have 8, 2, 6, 5, 4, 6, 0, 0, 3. And again, see, if you round that to the nearest thousands and you look at the number to the right, is that 5 or more? No. Then they see that would be 0, 0, 0. And they never want you to actually record 0 unless it's truly 0. So they would rather you round to the nearest 10,000s. When something like that would happen, they would prefer you round to the nearest 10,000. So tens, hundreds, thousands, 10,000s. Then you look at the number to the right. Is that 5 or more? Yes, it is. So add 1 to it. Okay. And then for the fraction, you have this here. So hit math. and then hit this frac, and then hit enter, enter down here, and then hit enter again. Oh, oh, and see how it didn't reduce? So the TI 84 did not reduce. Okay, so but we have even numbers, but we have even numbers in our fraction. So that means it is reducible. So you're just going to have to reduce the old-fashioned way, reduce by hand. So if I reduce by hand, 64 over 132,600. And um, you could reduce over and over and over again by twos, twos, twos. I did that. And when I was done, 2 times 2 was 4, times 2 is 8. When I did that, I had to do that 3 times by twos. And so now I know that 8 was the greatest common divisor. If I just reduce by twos, that gives me a common divisor, but 8 is actually the greatest common divisor that would allow me to reduce that one time. So 64 divided by 8 is 8, and 132,600 divided by 8 is 16,575. And I'm pretty sure that cannot be reduced again. Okay. So you may not see 8, and so you would just by hand you'd have to reduce it by 2, get an answer, then reduce it by 2 again. So let me just demonstrate that just to make sure you understand what I'm talking about. So you reduce this by 2. Half of 64 is 32. Half of 132,600 is 66,300. And then you reduce by 2. So 32 divided by 2, 16. And 66,300 divided by 2 is 33,150. And then I'm going to reduce this again by 2. And this is what I was saying, 2 times 2 is 4, times 2 is 8. That's how I know that 8 worked. So now half of 16, half of 16 is 8. And 33,150 divided by 2 is 16,575. And so now I know that it was reducible by 8. Okay. Okay, so now take a look at the next problem. I'll leave this here in case you're still writing. Take a look at the next problem, part C. And I'm not going to do the first 2 lines, like choosing a letter, which would be choosing a club, a spade, and a heart, and then doing the vocabulary with the and then the give. And I'm not going to do that again because it would be identical really to both of these last 2 problems. So I'm going to just save a little bit of time. If this were a test problem on the test, of course you're not going to have you'd have like one of these on the test. You're not going to have like we're doing over and over for practice. But on the test, you would to get the full credit. Yes, you choose the right answer. Yes, but then your teacher reviews your work and they count as template points. You know, you get a point for denoting, a point for the vocabulary in there. So you would get all those points for that. So that would come up with the full 5 or 6 points that it's worth. So if you only have the answer, you understand you don't get full credit. You've got to show your vocabulary. Okay. So look at part C and be thinking about that. And I'm gonna just I'm gonna get some water real quick and I'll be right back. But just to look at part C. Okay. I'll be right back in 5 minutes or less than 5 minutes. Just a second. All right. So as I mentioned, I'm gonna start with the idea. Like I'm not gonna recopy this. Let X denote choosing a club, a spade, and a heart. And then I'm not gonna write this down. This would be identical. This would be identical. I mean, if you want to be a little different, you could choose a different letter. It doesn't have to be X. Okay. But because we're choosing three, this is identical. Okay. And you probably saw that right when we did part A. I had used just J for Jack, but these were pretty much identical to what I just wrote, except I have X's on the other problem. These are J's, and the J denote choosing a Jack. So I'm not going to redo that for these last two. That they would be similar. Okay. Um, and so, but I am going to start with the detail, like getting a club. So when you look at your cards and you look at your clubs, these are your clubs. These are the flowery leaves here. Look at all your clubs. Looks like there's 13, right? There's 13 items in a suit, right? So when you're choosing a club, you have all cards in the suit of clubs, and so I can draw a club. Yeah. So there's 13 of them. There's 13 cards, and there's 52 cards in a deck. And there's 13 clubs to choose from. So that's your first fraction, okay? And then that would, represent this first fraction. Now when you choose your second fraction, given that the first one has been done, so remember you've got this 52 cards and you're choosing one of those clubs. So see, here's a club. See the five of clubs, but you're not gonna put it back in the stack. Okay. So now you're down to 52 minus 1 cards. So now you're down to 13 over 52 times, in the denominator you have 51 cards, because you're not putting this card back in the deck. Okay, but now your second thing that you're choosing, and now you're choosing spades. So what do we know about the spades? These are all your choices for the spades. And you also have 13 cards to choose from in the spade. And second draw a spade. Okay. So you have 13. So see, that's going to be 13 also to choose from. Okay, then you have the hearts. You have your hearts. And on your hearts, don't you also have 13 that you can choose from? All cards in the suit of hearts. So it'd be 13 of them. And so going back to the spade, oh yeah, so I did I ever pull out the spade? I don't think I pulled out the club. I didn't pull out a spade. Let me find a spade. Here's this. Let me see. Here's a spade. See that spade of 3. So let's say I pull that one out, and then I don't put it back in the deck. Okay. So now I don't put that back in the deck. So now I'm left with 52 minus 2. Take out these 2 cards. So now I have 50 cards now, because 50 and 52, I have 50 cards. Okay. So now when I get ready to choose my third card and I've got the hearts, I'm going to look for a heart. Okay. And so there's 13 to choose from. Okay. But then there's no need to keep subtracting because you're only choosing 3 cards. So there's no need to keep going with that idea. Okay. But that's what we have. And so now we're going to do 13 times 13 times 13. And you already know what the denominator is from the previous problem. You already know 52 times 51 times 50 from the previous problem. That doesn't change. That was 132,600. And then when I divide that, it looks like I get that. Okay. And I'm gonna run that to nearest thousands. Tens, hundreds, thousands. Now look at the number to the right. Is that 5 or more? Yep, yep. So add 1 to that. Okay. And then as far as the fraction, lowest terms, so this is not an even number. So, but let's see if that can be reduced. So now I just hit math, frac, enter, enter. And nope, it gives me back that same value. Okay, but that can be reduced. I played with it on my own still, and it is reducible actually by 13. 13 is the greatest common divisor. Yeah, so let me show you that. So let me say that the TI 84 does not reduce it, but it is reducible. And it's reducible by 13. So I had to play with a list of prime numbers to play with that. So let me show you. 2197 divided by 13 is 169, and 132,600 divided by 13, believe it or not, reduces to, yeah, 10,200. Yep. So this does reduce to 169 over 10,200. Yep. So it's a good idea to put a list of prime numbers. Have a list of prime numbers. So I have on this multiplication chart on one side, and I have my list of prime numbers. It's a good idea for you to write down these first few prime numbers somewhere as on a card or note card or something, 2, 3, 5, 7, 11. And what worked here was 13, 17, 19, 23, and 29. And usually the first line or the first two lines, if something doesn't reduce within the first line or the first two lines, and then chances are it's not reducible. And so it's good to have these prime numbers handy. And that's what I was playing with. Tried, I knew two didn't work because they weren't even. The top number 2,197 wasn't even, the numerator. But then I tried by 3, I tried by 5, I tried by 7, tried by 11. It wasn't until I was persistent I got to 13 that I found out, hey, that is reducible. Okay. And that's if they ask for it in lowest terms. I mean, sometimes they'll just ask for the decimal and they won't ask for it in lowest terms. But when they do want the fraction, then you want to have an idea of how to reduce it. Okay, and then this last problem on this page here, the part D, you're getting three clubs. Okay, so again, in your clubs, these are your clubs right here. There's 13 of them. So again, I'm not going to copy this down. Let X denote getting three clubs or choosing three clubs, and then you could change this to C1 and C2 and C3, and then you could recopy this, C1, C2 given C1 occurred, the third C3 given that the previous has occurred, C2 given C1. So you could just change these to C's. So I'm not gonna recopy that, but I'm gonna start with the clubs, and you've got 13 of them, 13 clubs, and those look like the flowers. And then you have 52 cards. And then the second one is another club again. So you've got the 13 take away 1 over the 52 take away 1. So now you have 13 over 52 times 12 over 51. Yeah, because if you pull out a club, let me find a club. You pull out the 6 of clubs. If I You have 13 clubs, so when I pull out, let's say I pull out the 6, I'm not replacing it. So now you have 51 cards here. And then now the clubs, you're down to 12 because you already pulled one out, and you have 12 other ones to choose from. And then now when you choose the third card, you're also choosing a club. So it's 13 minus 2 over 52 minus 2, which is 50, and 13 minus 2 is 11. Okay, so now you when you choose your second, you choose another club. I pull out another club. Say I pull out the club of sevens, take that out. So now I have two cards out. So now see I have 50 cards left because I pull those out. So I'm down to 50 cards. And then, but then there's no need to, I'm only choosing three. So there's no need to keep going. You're choosing three. So when I multiply across, 13 times 12 times 11. And you already know the denominator, 52 times 51 times 50. You already know the denominator is 132,600. And then when I divide 1716 divided by 132,600, and then I'm going to round that to nearest thousands. Tens, hundreds, thousands. Then you look at the number to the right. Is that 5 or more? Yep, that looks like that's a 9. So you're going to add 1. So that's going to be about 0.013. And let me see if that fraction can be reduced. If I do math frac, hit enter, enter. Oh, good, good, good. So that was reduced. So I don't have to reduce that on my own. That reduced. So that I just don't know where to put it. Where do I put that? I guess I put it over here. So that gives you 11 over, what does that say? 850. Okay, now we need to go back to page 113. Where's another one that doesn't deal with cards? It's still using multiplication rule number 2, but we're using batteries. So a flashlight has 8 batteries, 5 of which are defective. If 5 are selected at random without replacement, find the probability that all of them are defective. Okay. And so this is, we're going to use multiplication rule number 2. And the key word here is that it said without replacement. So it will, if you're working with cards, it'll say not replace. If you're working with something like this batteries, it says without replacement. Okay. And these are dependent events when they say that without replacement. Okay. And so I'm going to let D denote picking the defective batteries or defective battery or defective batteries. Okay. And how many are we choosing? If 5 are selected at random. Okay, so we're choosing 5. That's a lot. So probability of D sub 1 and D sub 2 and D sub 3 and D sub 4 and D sub 5. It's a lot. Okay, you're choosing 5 of them. And we go this way. So when you choose the first one, probability of D sub 1. And in your fraction, you're talking about these batteries. You're interested in the ones that are defective. So how many were defective and how many total did you have? It just turns out that you also have 5 that are defective. And you're also choosing 5. Okay, it's just coincidence there. But you have 5 that are defective and you have a total of 8 batteries. Not all of them are defective. 3 of them are not. Okay. And then when you choose the second one, probability of D sub 2 given D sub 1. So now you have 5 minus 1 because you already choose this one that's defective. You're not putting it back. So now you have 8 minus 1. Okay, so you have 5 over 8 times 4 over 7. So you start seeing this decrease. Okay, now, so, and I think I can use these. That's why I had these here. They pretend these are your batteries. These are actually olive seeds. Okay, so you have 5 defective. 1, 2, 3, 4, 5. 5 defective. Let's say these are your batteries. 1, 2, 3, 4, 5. 5 batteries here. And you pull one out and you're not replacing it, you're keeping it over here. So now you have when you pull when you I guess I should let that represent this. You pull it out, and now you have these left. So you had 5, 1, 2, 3, 4, 5, and then you pull one of them out. So there's the one that you pulled out. But now you have these left, and so you have 4, and oh, and now you have 7. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Oh, there's 8 of them. There's 8. There's 8, but these are the good ones. These are good. Okay, they're not defective. So now you're only choosing defective ones. So now you've got 4 that are defective, but now you have 7. See, 1, 2, 3, 4, 5, 6, 7. 7 total. That's your denominator. Okay, and then your third choice is probability of D sub 3 given that the previous event has occurred. So the previous event is this D sub 2 given D sub 1. Okay, so now so you have this battery, here, and now you're left with 5 minus 2, and 5 take away 2 is 3. So now you've got here this 3 batteries over 8 minus 2, and 8 over minus 2 is 6. So now you see you have 1, 2, 3, 4, 5, 6. Okay, 6 left. And now you just is 1 choice, 2 choice, 3 choice. You're choosing 5, 5. So now I gotta keep going. So now I'm running out of space. Oh no. Oh goodness. I'm running out of space here. Where do I put that at? Oh, where'd I put that at? Okay, I guess I'll put it down here. Sorry. So now I have, I'll put it right here. Probability of D sub 4. Yeah, 1, 2, 3, 4. Given that the previous account has occurred, and this is the previous account, all of this, D sub 3 given D sub 2 given d sub 1. Okay. So then this is the 1 right here. Okay. So then you've chosen here one that's defective, and now you're left with these here. So you have times 5 minus 3 over 8 minus 3. 5 minus 3 is 2. So you see there's these 2 lurking around. Over 8 minus 3 is 5. So you see 1, 2, 3, 4, 5. Remember, these are the ones that aren't good, and these are the ones that are left over defective. But that's 1, 2, 3, 4 choices. So now you got a fifth one. And so now here goes the fifth one. So you have the fifth one being probability of d sub 5, given that the previous has occurred. And then that would be all of this. Okay. That would be d sub 4, given that d sub 3, given that parenthesis d sub 2, given that d sub 1 occurred. Okay. So you're just recording the previous event, okay? And usually on a test, I don't go, this is really extreme, like 5. I usually don't go past 3 on these. I do the first 2 or the first 3 because I need you to demonstrate the vocabulary. And so yes, I look for the answer choice, right? But then you have to support your answer with your work. So the rubric, those count as rubric points for, like, let D denote picking the defective batteries, and it's using the vocabulary. So that counts like a point, 1 point, 2 point, 3 point, 4 point, 5 point, right? So the total is 6 points. So there's all worth points. And if you have the right answer, you get a point, but then you get points taken off if you don't show this work here. And you're allowed to use your practice tests. You have permission to use your practice test. So your practice test will jog your memory, just the numbers are different. And you are required to upload your work within 15 minutes, okay, for the credit. So no work equals no credit, okay? So you need to learn how to follow directions, okay? Okay, so then now we have 5 minus 4 over 8 minus 4. So 5 minus 4 is 1. So yeah, so once you pick this defective, now you're left with this 1 battery, and 8 minus 4 is 4. So you have 1, 2, 3, 4. 1, 2, 3, 4 left. Okay, that's this 4. And so yeah, that's kind of the idea how that works. So hope that little visual aid helps. So now when you multiply across, you're going to multiply 5. So I don't think we need these anymore. I'm going to take these off, okay? So now we have 5 times 4 times 3 times 2 times 1, which is 120. 8 times 7 times 6 times 5 times 4 is 6,720. And these n zeros, you can cross out these n zeros. They're like divisible by 10. For every n zero you can knock out. So that already can be reduced to 12 over 672. And if I get the decimal out of that, 12 divided by 672, here's your decimal equivalency. And if I round to nearest thousands, tens, hundreds, thousands, and I look at the number to the right, is that 5 or more? Yep, that's an 8. So I have 0.018. And then let's see if that fraction, if that can get a fraction out of 12 over. These are both even. So 2 will go into it, but let's see if the calculator would do that for us. So you do math, and then you want that frac, so you hit enter, and then you hit enter again. 1 over 56. So I can put that this is equal to 1 over 56. Okay. Okay, this is a long video, so if you need to stop and go do something, you can always stop the video. But I'm gonna keep going because I'm not really yawning. I get sleepy, start yawning. I'm gonna keep going because I'm not yawning. I was yawning a little bit earlier, but I think I need to finish this. So, but you can always stop the video and come back and look at that. Okay, let's see. Aha. Okay, this is another concept called conditional probability. And conditional probability, basically what we're going to be working with is a complex fraction. Okay. And basically what a complex fraction means is that in our numerator, or it could be also an, in our denominator, we have another embedded fraction. And basically what we would do is we would change the fraction bar into a division symbol. And then we would multiply by the reciprocal. Okay. And so this says the probability of B. Remember, this bar means given that, instead of such that we'll say given that. And this is that event A has occurred, and event A is considered the first event. So we have probability of A and B divided by probability of A. So it says the probability that the second event B, okay, so that's this second event occurs given that the first event A has already occurred, and can be found by dividing the probability that both events occurred by the probability that the first event has occurred. Okay, so they have a Venn diagram for that. And then they have this example about women in the military. A recent survey asked 100 people. So you see right here, this is your denominator. See that 100? That's your denominator. I don't know why they put the table twice. I don't know why they didn't need to do that. It's identical here. But the recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. The results of the survey are shown. So you have males and females, totals. Okay, just like we do our totals. Double check. And then there's a part A and there's a part B. So how do you know that you have to do this kind of math that I'm going to show you? The keyword here is they say given that. When they say given that, that's your keyword. So I'm going to put this up here. Keyword is given that. Okay. And I'm going to do the second example here. The second one. Go to the second one. Find the probability that the respondent was a male, given that the respondent answered no. Okay. So see this part was a male. That that is your second event. That's B. Given that the first event occurred, which was that they said no, that's A. That's the first event. Okay, so you have to use your vocabulary. Okay, so I'm going to write the vocabulary at the top. We just wrote that formula. I'm going to write at the top. And you got to write this down on your practice test. On your practice test, you have to write down you have one problem on your practice test related to this. So you need to write down the definition because you're expected to apply it. I'm just not interested in the final answer. You got to apply it for the full rubric points. And oftentimes you'll see on the practice test, I'll have lit B denote blank, lit A denote blank. So don't leave those blanks because those count as rubric points. And so for us, we're letting B denote that's the second event. That's the male. And we're letting A denote the first event, which in our case is the no. Okay. And then when we apply the definition, probability of the B, which is the male, given that the no has occurred. So this is uh, B given A, B given A. Okay. And so then we have this probability of A, which is no, and B, which is male, all over, see, probability of A, which is no. So you see this pattern, see when you check your work, these should be identical. These should be identical, okay? And so see how this is an and? So this is an and. So I'm going to do my outcomes. I have my no outcomes. I have an and I have my male outcomes. So for my no's, you see your no's, 18 and 42. Okay, and I don't need the 60 because this is not an or. If it were an or, I would write down the total. I would have a colon in the total, but this is an and. Male is 32 and 18. Okay, and then you see this overlap right here? And remember what happens with the and. On the ands, what we're supposed to do is we're just supposed to sum the overlaps. So we just have we have one overlap. We have one overlap, which is just the 18s. So that means that this is equal to 18 over 100. Because see, this is our denominator. So that's this probability because it's an and. Now if I had also like a 42 and a 42 here, and if I had to circle a 42, then I'd have 18 over 100 plus 42 over 100 because I have to sum the overlap. So if I had a 42 in both of them, then I would have to add all my overlaps. So then I have plus 42 over 100. But this one only had one overlap. And then the denominator probably of no, so probably of no, see, is going to just be 60. 60 out of 100. And so here's this right here. This is the complex fraction. That's a complex fraction. So remember what we said, this you rewrite it using the line with the two dots, this bar right here. So you have 18 over 100 divided by 60 over 100. And then how do you divide fractions? You multiply by the reciprocal. Okay, so first I change the long bar to this. That's what I did here. Change the long bar to this. And then now I'm going to multiply by the reciprocal. That means you flip, right? Reciprocal is you flip this. And this is not an accident. This will always happen. You see how these divide into each other, 100 goes into 100. That's not an accident. That's how you can check your work. That's how you know you're on the right track. That's always going to happen in your patterns here. So then you just 18 times 1 is 18. 1 times 60 is 60, and that reduces by 6. 18 divided by 6 is 3. 60 divided by 6 is 10. That gives us 3/10. Okay. All right. So I am gonna stop the recording, take a break, and then I'll pick back up, and then I'll finish. I have to finish 115 and 116. Wow, and 117, and then I had those extra two sheets. Remember those 3 sheets that I asked you to print? I already did one of those printouts, but I also have these extra practice problems. And I don't think they'll take very long. Yeah, because I did the other sheet already. And these are extras. The other sheet was from the worksheet from the workbook, but these are a little bit extra. So I'll do that when I come back. So it looks like I have 1, 2, 3, 4 pages and this one to do. So I'll do that. I'm going to take a break. All right. Okay. Take care.